Hi, so we left off talking a little bit about geography and introduced to you the idea of geography as a spatial discipline that's always interested in location, distance, and direction, particularly as from not just an absolute perspective, but also from a relative perspective. And we left off thinking about what are some of the ways that we can actually assess our location, our direction, and our distance. And we left off thinking about some of the technologies that are used commonly today. All of them, one of the commonalities was that it all had to do with global positioning systems. And so today we want to actually think a little bit about what is a global positioning system. We use the term all the time in our daily life. It comes up now to the point where you don't actually have to tell most people what it means anymore. But for most of us, we're not really sure how it's working. So let's just talk a little bit about that. The first thing we want to think about is the global positioning system, or the GPS, as it originated, is actually maintained by the Department of Defense, was originated through the Department of Defense, particularly for security issues related to national security and defense. If we think about it, it's actually a system comprised of satellites that orbit the Earth. Generally, there are about 24 operational satellites, often many more, and as you can see from the picture here, they all orbit in different patterns or different orbits around the Earth. At any given time, a GPS unit, or a global positioning system unit, that's what you think of as the little handheld thing, or your cell phone, or the navigation system in your car, at any given time, it can typically see about 5 to 8 of these satellites. So once it can see the satellites, what happens? Well, if we look, we can see that it uses radio waves and atomic clocks to figure out where the location of that GPS unit is. So in this case, the GPS unit sends out a radio signal, broadcasts it to the satellites. The satellites in turn send a signal back, and using atomic clocks, it calculates how long did it take for that signal to go and come back. And based on that, when it has that information from 4 or more satellites, it can triangulate the distance by using that time difference. So what does a GPS provide? A GPS can provide position, certainly absolute location, but also elevation. And I don't know about most of you, but frankly, I'm guessing that for most people, if I asked you what your absolute location is right now, you might be a little fuzzy on that one. So a GPS, while it provides absolute location to us, that absolute location needs to be converted into some type of spatial referencing system that we're all a little bit more familiar with. That's where we come into those navigation systems, what you actually see in your hand. Essentially, what we need to do is we need to convert our absolute location into relative location. So for example, if we look at this and we go to something like MapQuest, as to what many of us use if you don't have a navigation system in your car, or this is what it looks like when you do, you might look and see, well, what does MapQuest actually do? What does the navigation system actually do? It actually takes that absolute location, right, the latitude and longitude, and converts it into a system that we're more familiar with. In this case, addresses. Addresses are actually, while they have numbers associated with them, they're not actually absolute location. They're a form of relative location. So if you think about it, if you've ever kind of used MapQuest, or if you've used any of these systems, and you look at them, and you notice it'll tell you to go to, 150 South Street. And you drive along and you realize 150 South Street isn't exactly in the middle of the block like you might expect. That's because it's just taking an educated guess. Remember, our addresses, just like if you drive the house, my house may be 200, but the house next door to it may be 212. The one after that, 220. It may not be on a specifically measured mathematical scale. Rather, the numbers are just relative numbers. It's a number relative to the one next to it. So what the GPS can do is it needs some type of computer software, it needs some type of system that can convert that absolute location of latitude and longitude into things like addresses or countries or something that maybe we're more familiar with on a daily basis. So to do that, what we turn to a geographic information system, also known as a GIS. And a geographic information system, if we want a kind of a fancy definition for it, is an automated system for capture, storage, retrieval, and analysis and display of spatial data. Well, I don't know about you, but that's kind of a big mouthful of information. So what we might do is we might break it down into its basic components. The first part we want to think about is this idea that it is a database at its heart. So what exactly is a database? Okay. A database is an organizational system that allows you to store a lot of data, that allows you to organize it rather than just kind of throw it out there. It allows you to put it in some type of systematic organization. So for example, if we look at this and we look at what type of database information we might have, we can look at this address column. And our address column might be things like one part of our database. We might take this database and say 3350 45th Avenue Northeast is one component. It's one level. Well, what type of data might we have about that address in our database? We might include things like the name of who lives there. We might include something like their telephone number. We might carry it out and even include something like their income data, right, or their educational levels. And it's a way to take all this massive amounts of data and organize it in some system that lets us access it, retrieve it, analyze it, and then display it. So a generic database does that. And you might see it in something like, you might use a software product like Microsoft Excel or Access to do that. But what then makes it a geospatial database? Because that's what a GIS is. A GIS has a geospatial database. And what that is it's simply when that database includes locational information, as we have in this example here. If we come in and we look at our locational database, we said we've got addresses here. We've got our addresses, but then we could add in other columns of data, right? We've got our inhabitants' names, our owners' names. We could have the number of children living there. We could have the overall, what job category they occupy, what their education level is. But now we've made it geospatial because in our example, we also have a locational element, which is that address. Certainly our address could also be replaced with something like our actual latitude and longitude. But as we said, most of us don't function on that basis, so addresses are often the most basic and the most handy way of doing it. So once we have our database built, we've got our location and we've got the different characteristics associated with that location on the Earth. One of the other advantages of a GIS is that it isn't static. Because it's this computer system and it's a sophisticated way of organizing your data, one of the important things about it is that should one element of data change, you in turn end up with being able to update all of your other data. So if one of those things, one of those characteristics about one of these houses changes on our list, we can then go in and understand how then it reshapes our overall understanding of all those spatial relationships. And I know that's a lot to handle, so it's best, I think, to give you a little bit of an example when we talk about these things. And when we talk about these different characteristics, we refer to them as attributes, right, in our database, or characteristics. So for example, if we turn to our example here, we get some idea of perhaps, for example, we want to actually see where we want to live. We're in the market for buying a house, and we're not really sure, though, where we want to live, but we do have some characteristics or attributes that we think are very important in determining where we live or where we're going to make that kind of investment. So for example, in this image here, I have a couple examples of some of the attributes that people might consider when they want to buy a house. So for example, we can look at this top one, and that's crime prevalence. And based on our, we said, remember, maps are generalizations and symbolizations. So the most common one is that darker red areas are going to be associated with more crime, lighter areas with less crime. We also know that if we want to buy a house, we're going to be limited to areas, or if we wanted to build one, to areas that are actually zoned for residential housing or residential construction. Okay? If we go on, what other things might we look at? If we look at the top on the right-hand side, we might look at it and look at something like property values. For me, we may decide that we have a very limited budget and we want to buy within a particular range of property values. As you can see in this image here, the property values map indicates that some of the most expensive areas are in the northern areas or in the southeastern areas. And then the last one we get to are schools. Perhaps we have children, or we work near a school, or we want to have some tie to a local school. And so we don't want our kids walking more than a certain distance from that school or having to commute too far for that school. So we may actually look at our schools to decide that where the location of schools is very important to where we want to purchase a house. So one of the things is we've now got these 4 attributes we've looked at, but we want to now understand how these attributes interrelate with each other. How do they actually tie in and overlap with each other? And we may also certainly decide that some of these attributes are more important than the other, because we want to create a model that allows us to identify what we would consider our hot spots. Where are the best places for us to live according to our criteria? And so if we add these things together, we layer these different components together, these different attributes. Each one is a layer, and we put them on top of each other so they all tie in. And we weight them according to what our preferences are. We then might end up with something that looks like this to give us an idea of our preferred residential areas. So if we look at this, by simply layering all the data in, we can come up with some of the best areas that would be right for us. In this case, we can see in the northern areas and the western areas, maybe the south isn't so much for us in this particular town, but it gives us some idea of understanding how these different characteristics can relate to each other. Think about it. In the past, maps could only apply one of those things to each other, and you'd have to sit there and look at every single map and try to compare them up. What we've essentially done is layered them on top of each other, but also allowed these different things to be weighted according to what we felt was most important for our decision making.